Welcome to the new project. Imagine turning your webcam into a personal yoga coach, one that watches your movement, challenges you with poses, and gives instant feedback in real time. In this project, we're building the Yoga Pose Mission Game, an interactive web app that combines computer vision, AI, and game mechanics to make pose practice more engaging and fun. Instead of passively following a video, you're given a clear mission. Hold a specific yoga pose, wait for the countdown, and see if the AI recognizes it correctly. By the end, you won't just have a working AI-powered game, you'll have a practical example of how machine learning, real-time video processing, and front-end logic can come together to create an interactive experience. Let's jump in and see how this yoga pose mission comes to life. Okay, let's get started. Now let's zoom in on what we're actually going to build. In this project, we're creating the Yoga Pose Mission Game, an interactive web app that uses a live camera and an AI model to make yoga practice more engaging. This application is built by slightly modifying and extending the rock, paper, scissors game we created earlier, so the overall structure should feel familiar. The goal of this program is simple and beginner-friendly. Just like the previous game, the app runs in rounds and gives you a mission each time. The key difference is the mission itself. Instead of showing a hand sign, the app now presents a yoga pose. A countdown starts, and at the right moment, the program checks whether the pose you are holding matches the mission. If it matches, you clear the mission and earn a point. This repeats across multiple rounds so you can track your score. When the program runs, you'll see your live camera feed on the left side of the screen, with pose detection happening in real time. On the right side, a mission pose image appears along with text telling you which pose to perform. A countdown starts from 5 and goes down to go. For example, if the mission says hold this pose, down dog, and the camera detects down dog at the right moment, the screen shows mission clear and your score increases. If the detected pose does not match, the round is marked as a miss and the game moves on. Behind the scenes, this project uses core Python concepts you have already learned. Variables are used to store the current pose, score, and round number. Loops control how the game repeats across rounds. Functions help organize logic such as starting a round, running the countdown, and judging the result. Flask routes handle communication between the browser and the Python backend, while threading allows the live camera and game logic to run smoothly at the same time. Dictionaries are used to manage shared state safely. This project shows how a small change to an existing idea can turn a simple game into a more practical and interesting application. You're not starting from scratch here, you're building on what you already know and taking it one step further. In the next step, we'll walk through the game flow step by step and see how the rock, paper, scissors logic was adapted to work with yoga pose detection. Now let's take a look at the folder structure for the Yoga Pose Mission Game. And the nice part is that it's almost the same layout as the rock, paper, scissors mission game we built earlier. That model file comes from your previous training project, so we're not rebuilding the machine learning part from scratch. We're simply reusing the trained model and plugging it into the same mission-style game flow. Then the static folder, and inside poses, we store the mission pose images, like down dog, goddess, plank, tree, and warrior, so the player can see the target pose clearly before the countdown starts. So overall, this is a small focused upgrade from the earlier rock, paper, scissors project. Next, we are focusing on the front page of the project, the main HTML template that builds the user interface you see in the browser. The nice thing here is that we did not rebuild the layout from scratch. This Yoga Pose mission game is a small upgrade from the rock, paper, scissors mission game we made before, so the overall structure stays the same. We still keep the screen split into two big areas, the live camera view on the left and the mission and scoring panel on the right. What we changed is mainly the text and the labels, so the experience matches a yoga mission instead of a hand sign mission. The title at the top now says Yoga Pose Mission Mode. The description explains that you will hold a pose until go, and the badges and section names are adjusted. On the right side, the same mission panel is reused, but the meaning changes. Instead of showing a computer hand, we show a mission pose. The user still presses start, sees the mission, waits for the countdown, and then gets judged. So the flow stays familiar, and that is the point of this change. We reuse a proven UI and simply swap the theme and wording to fit yoga. So when you look at this file, think of it as a layout template that is already working from the previous project. We are just updating the visible text, so the app feels like a yoga pose game while keeping the same reliable structure. In the next step, we will move from the page layout to the server settings and update the configuration in the main Python file so it connects to the yoga pose model and supports this new mission logic. Next, we are making a small but important update to the configuration in app.py based on the rock, paper, scissors mission game we built earlier. The first part stays familiar. We still load the trained YOLO model from the weights folder. We keep the confidence threshold and image size, and we still open the webcam using camera index 0. So the overall setup and flow are the same. The key change is how we define what counts as a valid label. In the rock, paper, scissors version, we hard-coded a short list like rock, paper, and scissors, plus the outcomes win, lose, and draw. For the yoga version, we do not want to hard-code pose names because the model classes can change depending on what you trained. So instead, we lead the class names directly from the model. We take the model class list, clean each name into a safe format that works for matching and for image files, and then build a final list of valid poses. That is how we end up with a list like down dog, goddess, plank, tree, and warrior 2. And finally, we update the round storage. Before, each round saved 2 values, the computer hand and the target outcome. Now each round just saves 1 mission pose, because the mission is simply match the pose that the model expects. So the main idea here is simple. Same structure, same config style, but now the mission list comes from the model itself, which makes the game flexible and reusable. In the next step, we will use this updated configuration inside the camera loop and prediction flow, so the live detection can output the user pose and compare it to the mission pose in real time.